This is keeping a MySQL slave in sync using mk-table-checksum and mk-table-sync. And after we do that, Matt will go through some of the other Maatkit tools that exist. And if you have specific questions about other ones, then we can all talk about that. So, I should probably point my thing towards me so that I can do it. So why would a slave be out of sync? Like, why do we even need this in the first place? For the most part, probably 99% of the time, somebody's writing to the slave. Either realizes they're doing it and, oh, we're just doing some ETL on the slave, we don't need to do it on the master, but they're changing some important data that shouldn't be changed, or, they don't realize they're doing it because at one point the slave was the master, and when they changed, propagated the old slave to the new master and the old master to the new slave, they didn't realize that this script was running directly against it, changing data, and so you have that. So that's most of the time that's what that is. Starting the slave at the wrong binary log position. I used to do this all the time because when you do a show slave status, or you look in the master.info, whatever, there are a lot of different numbers, especially in show slave status, and in show slave status you have two different sets of binary logs and binary log positions. One is for where it's reading from, and one is for where it's executing from. Because the replication is a two-threaded process, right? You have one I/O thread, which is what it's called, which goes to the master, gets the binary log statements and saves them in a relay log. Then you have the SQL thread, which reads from that relay log and then executes those things. So when you, let's say, take a backup and put it on a new server or whatever, and you start it, what you really want is you want that execute position, not the read position. But the read position is what shows up first in show slave status. So it's a mistake that I've made often. But obviously if you skip some things or you do it again, then you're going to have different data on the slave than on the master. Statement-based replication. If you have a little bit of discrepancy in your data and you're using statement-based replication, if you're doing an update based on some where clause, and the where clause is different on the master and slave, then you're going to update different data. And statement-based replication, if there's like a network error, and you don't get that statement for some reason, hard to prove, but at least with row-based replication, if you miss an update or something, the next one will kind of move the rows over. Hard to do with inserts and deletes. But with row-based replication, you at least get, you could kind of recover if you did skip something. Non-deterministic writes. So a deterministic query or deterministic function, let's say, is something where if you put a certain input in, you'll always get a different input out. For example, 1 plus 1, always going to give you 2. No matter when you do it, where you do it, it's always going to give you 2. Select now is not deterministic, because if you do it in a second, it'll give you a different answer than when you did it now. MySQL's replication has a few tricks. So for example, now actually is deterministic in replication because it saves the timestamp in the binary logs, which is why there's all that set timestamp, set auto increment. That's why it's there, so that you make sure that those kinds of queries aren't going to happen. Rand actually will save the seed in the binary log, so with that, if you use the rand function, it actually will not screw up on replication. But there are some things that are non-deterministic. And in fact, mk-table-checksum itself uses something that's non-deterministic on purpose to get a different value on the master and slave, possibly, which is actually kind of genius on that part. What it does is it checksums the data on the master and checksums the data on the slave. And so obviously you want to know if there's different values, right? You don't want it to just insert the same thing. You want it to insert a different one. Because if the slave is different than the master, you want that to work. So sometimes you want non-deterministic writes, and some people have made hacks to do that. But for the most part, you don't want that. We've actually run into some people. One of the examples we had when we started doing this checksum, when we did a continual replication syncing checksum, which is basically a fancy way of saying always look at some part of the data to see if it's out of sync. We actually found that one client was using sysdate. Sysdate is not like now. Sysdate uses the system timestamp. And they actually had one server on the East Coast and one server on the West Coast. And in fact, all of their West Coast data was, the timestamps were 3 hours different. And so the checksums came out wrong. So that's another example of non-deterministic is using sysdate.
Well, sysdate's bad even if you're in the same time zone. It's about when it executes, right? So if the slave's 10 seconds behind,
Right, it's about when it executes. Exactly.
So state is very bad.
So if the slave is 10 seconds behind, or even if the system time is different, you could have one, and if you have two boxes in the Eastern time zone, but the one box was set up to use UTC and one box wasn't. So yeah, using sysdate isn't necessarily a good idea. However, we'll get to a fix for that actually later in the slides. So another thing, slave restarts an in-memory table. If you restart a slave, and it was in the middle of like a temporary transaction kind of a thing, those in-memory tables go away because it was temporary table or an in-memory table, they'll go away. So again, that's kind of part of non-determinism and the rights on the slave being different. The statement-based replication will be different because you don't have those temporary tables to get from. Dependencies on non-replicated data. So again, if you're doing writes based on what's the data that's there and the data is not there, non-unique server ID. Server ID is what MySQL uses to determine whether or not that statement has been applied or not in replication. This is why you can do things like circular replication or master-master replication, and you don't get a never-ending, let's keep writing the statement. Because basically, if I have server ID 1 and a machine over here has server ID 2, and let's say we're master-master, so I have a write and server 2 has a write. Server 2 writes and puts my IO thread writes everything to the relay log. The SQL thread, when it reads the relay log, will say, is this my server ID? If it's my server ID, don't apply it. If it's not my server ID, apply it. So if you have two things with the same server ID, like you could actually get a chain of, let's say you have a master and a slave and then a slave under that. If that slave has the same ID as the master, then it's not going to really write anything because it originally keeps coming through that. Hard to pinpoint, so network errors are hard to pinpoint, right? It's a little easier to pinpoint if you have some of the other problems we were talking about. You might not know where it happened, but you could look at the binary logs. You could say something wrote on this machine, because in the binary logs it says what server ID it came from. So you could say, oh, this write happened last week on this server ID. It should have happened on the master and propagated. That's why it's out of sync. Network errors are harder to detect. Like if there's a dropped packet or something, this is one of those. It must have been a dropped packet because none of the other stuff is there, or a MySQL bug, for example. And I'm sure that there has been, replication out of sync caused by these, but I can't really pinpoint that bug caused it to happen, or that network error caused it to happen, because those are just, it's hard to figure out by nature. Although Matt, if you have any confirmation or denial, no, that never happens, or yes, I've seen that happen too. Feel free to jump in. So let's talk about the real nitty-gritty. How do you sync the slave? Well, the first thing I like to do, you could just sync it. Right, you could just say, oh, out of sync, let me take the backups and refresh the thing and I'm done. But then, the talk would be over and we'd still have half an hour to do nothing. So let's talk about syncing this. In a real world scenario, what you want to do is you want to find out what's out of sync. Because you want to figure out, is this something that's out of sync one time? Or is this something that's always out of sync? For example, the sysdate example. That's something that even if we fix the data, if we went back a month later to try to check it to see if it was okay, it would be out of sync again, but only the stuff that we hadn't fixed in the last month. So find the out of sync tables. How do you do that? Well, I like to use mk-table-checksum on the master. There are different ways to use these. I'm going to show you the ways I use them. You can run mk-table-checksum on the slave and use different options than I do, and it's fine. I like to run it on the master, and the way that I like to run it is you run it on the master, you give it a table, it'll write to that table, and then it'll propagate to the slave, and then you check that table on the slave. So this is how I usually do it. Perl mk-table-checksum localhost, so you're doing it on the master, you're connected to the master, your user, do ask pass on command line, and replicate Maatkit.checksum. And Maatkit is a database that I set up. The checksum table is the table that it will write to. And so what that does is it'll go through all of the tables and all the databases and checksum them and put them in there. But what this does is it'll checksum the whole table. Now, it doesn't necessarily lock the whole table. It might. We'll get to that in a second, but you can also specify chunks. So for example, you could say, I want to, okay, and when you do a first run, you do -- create replicate table, because that checksum table didn't exist. So I think I have an example here, and I should probably point it there, not up there. Perl language, localhost user ask pass replicate Maatkit.checksum and see create replication table. That's what you do on the first run. If you do it on subsequent runs, it's not going to be a problem. So I usually just leave it in there. It uses a numeric index, which could also be a date or a time or a date time. Anything that's basically a number underlying, it'll use that numeric index to kind of, do that checksum so that it's not locking the whole table. But it could lock the whole table if you don't have that numeric checksum. And it doesn't give you any warnings or anything. It doesn't say, hey, by the way, you've got 50 million rows and I'm about to lock the whole table. Because, that's just not the way the tool works, really. Although, I guess it would be neat to say, hey, warn if I'm doing more than, 10,000 rows at a time or something like that. But you can, like I said, you can use chunks. So chunks also use numeric indexes. You give it a modulo and an offset. So basically, you divide it into X number of pieces. You say, like, okay, divide it into X number of pieces using the numeric index, and then do this piece. So, for example, mk-table, the first two lines we know, chunk size 1,000. That's going to do 1,000 rows or approximate 1,000 rows based on the metadata. Modulo 21, offset 7. What that means is divide it into 21 parts, and the offset is 7. So on this one, I want you to do part 7, which would probably be like, the first part would be 0 to 1,000 rows, rows 0 to 1,000, part 1 would be 1,000 to, or whatever. And it's using modulos, just, standard modulo, the mathematical thing. So that will do, approximately 1,000 rows. The chunks may not be exact, and there's no warning of no numeric index. So if you do this, and there's no numeric index, it will chunk the whole table. And then you go and you do modulo 21 offset 8, and it'll do the 8th piece, and it will do the whole table because it can't cut it into chunks, and there's no warning.
So what does numeric index here mean, like a auto or a primary key?
No, it's an index on a number, and it doesn't have to be primary. That's a great question. It doesn't have to be primary or unique index.
Okay.
That's why the chunks may not be exact.
Yeah. Because
let's say you have orders, and you have 6 different orders, and you split it into 21 parts. It's only going to really be able to be split into 6 different parts.
What is it applying the modulo to?
I'm sorry?
What is it applying the modulo to?
What is it applying the modulo to? Great question. It figures it out. I mean, that's the work that mk-table-checksum does for you. You don't have to say, it's not like partitioning. You don't have to say, do this column. It will find an appropriate column for you to do, or not. And that's kind of why it doesn't really give you an error, because you don't have to worry about that. So it's trying not to make you worry about that. So if there is no index to use, it's not going to yell at you, because then you would be like, what do you mean there's no index to use? Just chunk it. It's trying to be user-friendly and nice without overburdening you with information.
But you can overburden it with information if you want.
Right. You can even say checksum this column, checksum that column, and it's not going to use other columns to divide it up. So you can give it others. Do you remember the command to?
Well, I know, like I've seen several people actually use like the where portion of it and pass in like the timestamps. They have an updated column, so they'll just say where updated in the last 7 days. So
right. You can do save since and all that kind of stuff.
Yeah.
So yeah, you can do that. I found that this can and cannot work too, because it also does it based on the table. So your table doesn't have a timestamp. I mean, if you're checksumming, X number of tables, most clients that we put this on were like, just checksum everything, because they want to know everything that's different, and not every table has a timestamp.
The module applies to the size of the table, not the chunk size. So
correct.
It
correct.
breaks
the chunk
the
size is 1,000. So the modulo is
21 parts of the table.
right, and I did say that.
Offset 7, got it.
You're right. So let's say there's however many thousand rows, such that 1/21th of the data is 3,000 rows. It would do 3 chunks.
Got it.
I did say that wrong, so I'm sorry about that. So yeah, so finding out of sync data. So how do you find which data is out of sync? You query the slave. So after these have run, you select some fields. So database name, table name, boundaries, which I'll show you what that is in a second, master count and this count, and timestamp is the timestamp that the checksum itself run from the table we just had, where this CRC does not equal master CRC. That's the checksum. And DB does not equal Maatkit, because you really don't care if the Maatkit tables are out of sync. You're kind of expecting them to be out of sync if any of the data is different. Because if any of the data is different, then your table is going to be different, and your table's in the Maatkit database. You also, if you have different users on both hosts, you might want to say ndb does not equal MySQL as well. And I think it's smart enough not to check information schema. So
I hope so.
I know that I've never put in DB non-information schema, which means it's never come up as a problem to be different.
It is hard for them to do that.
Yeah, 'cause
It's
it's
hard
not
for
a
it
real
not to be that.
database, so it would be silly for it to check.
The other important thing to note that I didn't put on any particular slide, but here is as good a point as any to say, it only checks to see that the data is different. If the schema is different, if you have different indexes, it doesn't check that. It only checks that the data is different. Now, if there's a different column, then you'll probably end up getting a replication error because it's going to try to check some that column and it doesn't exist. So you probably will get, if there's like a column missing, you'll get it, or the table's named differently, you'll get it because it'll try to check some the table, it doesn't exist on the slave. And then the other thing to note is, if something exists on the slave but not the master, like a whole table, you're not going to get a checksum for that at all. So you may not even know that it's not being checksum because it won't show up in this query, but you don't know if it didn't show up because it didn't exist or because it's not there. So, go ahead.
Are you replicating the MySQL-checksum?
Yes, the MySQL-checksum table is replicated.
Okay, all right. So then you're on. Okay.
Yeah, you do have to replicate that table, otherwise this won't work. Because that's why you have to query the slave, but you run the command on the master and all that kind of stuff. So one of the interesting things is, if you get no rows returned from this, that's wonderful. However, you should make sure there are rows in the MySQL-checksum table. Because if it doesn't replicate, let's say you're not replicating it, or let's say the slave is broken, or if the slave is broken, actually the mk-table-checksum may or may not work. I think put that in as a bug that it should work, or it should give you a warning, not an error, and stop. I know in previous versions it stopped and just said, I can't do the replication, I can't do mk-table-checksum because the replication broke. But anyway.
One of the other odd things is sometimes the CRCs match, but the counts are different. So
yeah, but the counts. So you could have a longer query, but usually you're going to get the count, the CRC is different. I mean, that's the whole thing about checksums, right? It's not using a.
Yeah, I've run into it more times than I would figure that I would have. So
Really?
why, yeah.
Really? Okay. So the boundaries are actually the where clause, and we'll see this in a second. So this is what I recommend doing because I actually also will put that into the output of a monitoring script, so I don't want to see everything. The next slide I'm going to show you all the rows. It's going to show you a select star. I try not to use select star unless I need to, but this is what the whole table looks like. You've got the data, and everything in bold is what I recommended you actually select. Database, production, table, food, chunk is 1176. So again, that's your 1,000 rows or whatever, 10,000 rows. Boundaries, see ID is greater than or equal to that, and ID is less than that. That's the actual chunk. So in this case, it is actually, is it 1,000? Something like that? It's, I don't know exactly what it is. It's 10,000 maybe, because it goes from 11841 to 11851. So it's about 10,000 rows. So here's the checksum and the master CRC, but you can see there's actually different numbers too.
Yeah.
And then the timestamp, that's when it was done. So that's interesting that the CRCs were different. I always kind of assumed that they weren't. So I would probably change that to where this CRC, put parentheses, this CRC does not equal master CRC, or this count does not equal master count, and DB does not equal Maatkit. So just as a tangent, if you did this continual replication sync checking, you can use a dynamic offset. I showed they used like 7. If you were really checking to the sync, you would try everything. So you might actually do the modulars, but you would do it 21 times in a row. I picked 21 because this was an example where we were syncing it every day. 3 times a day we would run this by a cron, so within a week we would have checked all the data. Now this is a continual thing because what happens is, it's Sunday at midnight, you check 1/21st of the data, right? And then Sunday at noon, you check whatever. Sunday at, 8 a.m. you check, I'm trying to divide by 3. 8 a.m. you check, the second offset, and then you check the third offset. But data might have been changed in all the things in the first offset. But the idea is right now you're not checking at all. So if you find errors within a week, that's a whole lot better than now where you find it when it trips you and bites you in the butt. So a lot of people are like, what do you mean? And some people who have like 500 gigabytes to really not lock their tables, because the other idea is you could checksum the whole table, but it would take a while, and it does add processing and all that kind of stuff. So there's some people who have like 500-600 gigabytes in their database where we're like, yeah, it takes 3 weeks to, if we're doing a checksum every hour, and it takes 10 minutes to do this checksum of this, 1 gigabyte of data at a time, whatever. It will take like a week or 2 weeks. They're like, what do you mean it'll take a week or 2 weeks before we find problems? And then I have to explain to them that right now we're not finding them at all. Like, they just assumed replication would just work like it should, and you never have to check this thing. So you'd use a dynamic offset. So this we're familiar with. It's in a script now, so you don't use AskPass. You actually put the password in the script. Modulo load 21, chunk size 1,000. Offset is now everything after the word select in a select statement. So you would make a table in the Maatkit database called checksum modulo with one column called modulo offset. This could have been anything. It could have been foo from bar, from maatkit.bar. It doesn't have to be that specific ones. I just gave them those names because they're very easy to do. And so in my database, checksum modulo has one column and there's one row in it, and it's whatever modulo it should use. You could run it from cron, and then you would look on the slaves regularly for differences, which you could make a monitoring script to do, which is what I did, which is why I only put like DB table boundaries, and the counts and whatever, so that when I get, when I look at the dashboard of the monitoring thing, I don't get things like that I don't need. So now what? So we have the data. We know there's some data out of sync. We've got some, this database and this table, has 50 rows different. Now what do we do? Well, I like to figure out why the data is out of sync. So I will actually go and find the differences by doing a MySQL dump on the master and slave using the -- where clause. Okay, so you basically take this chunk, this ID, I do it on the master and the slave, and then I do a diff of the file. Now, diff won't point out what exactly is wrong, but it'll point out which lines are wrong. If you have something where the count is off, it may be that the only differences are those rows, or there may be something different in all the things too. We found some issues before. Like, one of the things we had is if you have a floating point number, it might be different. So there's actually a parameter to mk-table-checksum for floats where you could say only go to a precision of 7 digits, not 12. Because what we had found when we did a diff was that every single column that was a float was like the last digit was 1 off. And that was actually caused by the fact that they were using 2 different minor versions of MySQL, but we didn't really care that the very last number was like float precision, because it was like 12.0072157.2, and that was a 3 on the other one. We're like, that's close enough. So actually, the client said that was close enough. We didn't make that decision. So use diff to find the differences. So okay, so you know what the differences are now. Well, we'll fix the systematic issues. For example, we talked about sysdate. There's a parameter called sysdate is now, which basically makes sysdate an alias to now. And as we talked about before, now is actually deterministic in replication. So in this way, they didn't have to change any of their code. We put this parameter in the server. It's -- sysdate is now, but you put it in the MySQL configuration section. So that was something we found. We found rogue scripts just running out of cron on slaves that used to be a master, or there used to be a dev server and they're running. So they're actually just writing data, but it wasn't somebody going in and writing data. It was like, oh, we didn't know that script was still running. You can do it. Really? You can't? Oh, they're from out of battery or something. So deterministic info, so are you writing that using row-based? So, you might say, you know what, we have a lot of this stuff, let's just use row-based, or let's just use mixed binary log formatting so this doesn't happen. Yeah, I think the battery might be down on this thing. Okay, so the other thing to do, so once you fix the systematic things to say, okay, this isn't going to happen again. It's like if you have a water spill, right? You want to turn off the water first before you start cleaning up the mess, right? So that at least there's no mess coming down the pipe. So fix the data, fix it by hand if it's easy. For example, update table set time field equals time field interval plus 3 hour. Then you don't really have to worry about sync. You run the checksum again. You're like, oh, the data's all fixed. Great. If it's too difficult, just refresh from backup. Just take a backup and refresh. So for example, if you have like 100 tables with lots of foreign key dependencies, and those are foreign key dependencies on this, and this is foreign key dependencies on that, even using mk-table-checksum is going to be a pain because it doesn't do that whole what's the foreign key parent relation thing. So we've done it, and it's like, oh, well, I tried to insert into this table because it was missing, but it was missing and the parent's missing, so I couldn't insert to this table because it had a foreign key, and that one was missing too. And sometimes it's, when it goes more than like 2 or 3 levels deep, you're like, screw it, we'll just refresh it from back. For the most part, though, you're probably going to use mk-table-sync. You can run mk-table-sync on the slave or the master. Yeah, that's still not working. That's annoying. I usually use the -- verbose mode. That tells you every chunk it's doing at the time it's doing it and what the CRC is or whatever. -- print will show you the queries that it wants to execute to make things into sync. So might delete some rows, it might insert some other ones. -- replicate. So I like to run it on the master with -- replicate. And I'll show you all the ways to kind of run it. But if you run it, or not on the master, if you run it from anywhere really with -- replicate, and you give it a DSN, which is a host and a user and password, it assumes that host is the master. It figures out what slaves are connected to it, and then it will sync all the slaves. So now if you run it like this, if you don't run it, so for example, this does not run with the -- execute flag. So what this does is this will make you a file of commands with chunks in the middle. And I put it into runme.sql because the idea is after that's done, you can run that file and you'll be good. I forget if the verbose is, I think it's commented with pound, so you could actually just run the file by hand. So this is something I like to do just because, and that should say Maatkit.checksum, not heartbeat.checksum. That's just my copy and paste stuff. But this will go to master host, and connect with user and password. But you could run this on a machine that doesn't even have a database. If master host is remote. So you don't need to be on a master or a slave. You can run on anything actually. And that's how I would do it if I have, I actually just did that a couple weeks ago on a server where there were like 5 slaves on one master and all 5 slaves are on a sync and they were all on a sync the same way, but I didn't want to take that chance that maybe one of them was on a sync differently, so I just said, just sync all of them. If you run it, here's how I do it. See the -- execute, that's in bold. I basically say, look, mk-table-sync, I trust you, but I want to see what was run. So I'll do this, I'll do the printed verbose with execute, and I'll put that into a file, and then later I can check the file. But that's also, different clients I do different things on, but if you're relatively comfortable with it, you could do that. If not, you could do what I showed before and then run that SQL and whatever.
So with that, this is run on the master. You're not specifying any IP addresses of any slaves.
Right.
You're simply saying replicate that table, heartbeat checksum.
No, what that is, the heartbeat.checksum is actually saying using the checksums in that table. So that's how you know which ones are.
There's
that's
a
how you know
table
which
called.
ones are wrong. That's really.
There's a table called heartbeat.
It's a database called Heartbeat, but it's really, remember I was using Maatkit as the database and checksum as a table name?
Oh, okay.
That's really what it is. I just, I copied the wrong example when I copied. So it uses that. So if you don't have that checksum table, it's going to be like, okay, sync is done, and you're like, no, it's not. You didn't do anything. So, so you have to do that. So the other ways to use mk-table-sync, so replicate without sync to master, which is what we just did. The master is the DSN, so the DSN is that user host password that you saw, that string, this one. This one that you saw with the H equals master host, that's called a DSN. I forget what that stands for, but basically,
Data source name.
Data source name. It's like a standard in the industry, and certainly standard within MySQL, within Maatkit. So replicate without sync to master. The master is DSN, find the slaves and sync them. -- replicate with the -- sync to master. So if we had -- sync to master there, what that means is you run that on the slave. That's saying, hey, this is a slave, sync it to its master. So if you have a master and 5 slaves and you only want to sync one slave, because let's say you know all the other ones are out of sync, or you just like to do one at a time or something like that, that's how you would do it with -- sync to master. You can also, if you don't put the -- replicate flag, you could actually sync to master with one DSN, like we had one DSN there, and that says to run on the slave, and it will connect to the master, just like the last one, and sync it there. If you have more than one DSN, so you don't have sync to master, you don't have replicate, but you do have more than one DSN, what it assumes is the first DSN is the master, and the rest are the slaves. So if you wanted to, you could say, okay, sync this one to 10 different slaves, and you would have 11 DSNs.
So, but does sync to master mean it's still using the master as the authoritative copy, right?
Yeah, it's using the master as the authoritative
Okay,
copy.
because the name sort of implies to me that it's taking the slave as authoritative and updating the master.
Yes. Well, no, it's updating the slave. It's using what's on the slave, and yeah.
Oh, it is doing that.
Sync to master means sync it to the master so that I have what the master has.
Yeah.
Do you,
I just find the preposition a little.
Maybe sync from master.
Yeah.
Yeah.
Well, you know,
File bug report.
does
Yeah.
this doesn't actually require any replication to be going on between either. The
does it
con-
require
the-
replication to be working? Ooh, I forget, because I
No,
usually
you
just use
can
the wait
use
command.
mk-table sync between two without replication. You just can't use the replicate option.
Okay.
So,
Right.
so you can have, we've actually done this where, for whatever reason, like somebody needs, like a box setup that has like a copy of the data at night from production.
Yep.
Run this nightly.
Yeah. So so the workflow for that kind of model, where you don't want replication going, but you want kind of this quasi-replication to occur every 4 hours or
Like
something
you
like
want to
that.
sync, let's say you want to sync like some static tables, right? But you don't care about the dynamic data. So you want to make sure like your countries and your cities are all the same, let's say.
Yep.
You can do that. And there's a dash databases option, so you can pick which databases, dash tables, you can pick which tables.
So you don't need to do the pre-check summing if you're always like making sure table to table is.
You don't need to do it. I like to do the pre-checks. I like to do the pre-check summing only because I actually like to always be running that continual replication thing. I don't want to ever have to go like, let's go see if it's in sync, because let's say there's a bug in mk-table-sync and it's not syncing, or you mess up the commands and it's like, okay, I'm done, and you think it's in sync and it's not. So I actually run the checksum afterwards too, to make sure, and or even not the checksum, or mk-table-sync with without the dash execute, but with the dash print to see, because in the early days of mk-table-sync, it just didn't work, or I don't know if it didn't work or I did it wrong or whatever, because the documentation wasn't always easy to read. I would have problems because I would go and I would run it like with print, and then I would run it with execute, and then I'd run it with print again, and it would print out the same stuff. And maybe, I forget if I was using the table or not, but maybe that's because it was looking at the checksum table. So it's like, I always like to check some before and after, just to make sure, like, yes, it did something. You know, and it didn't find anything else out of sync. You know, so that's just the way I do it. That's just my own paranoia.
If you're not replicating that checksum table though.
Yeah, if you're not replicating the checksum table, then checking via replication isn't going to help, right?
Okay.
So.
Well, you can create the checksum on each of the tables and then compare them. Just hope you do it that way. Like you could copy it over.
Yeah, the problem is that, yeah, it would have to be on a totally static table, right?
Yeah.
So yeah, you could do it that way, and certainly there are also options, like there's actually, if you're using MyISM tables have a checksum flag in the create table. So if you do like alter table name checksum equal 1, just like you might say engine equals, you know, MyISM, there's a running checksum that is actually in the show table status and the information schema tables. There's actually a checksum field. So it's it actually keeps a running checksum of it. It's like doing checksum table name, but without having all that locked in, which is pretty cool. And it's been in there since I think like 5.0. Because I looked at like, is that like a new feature? No, it's not. It might have been there since 4.1.
I think it was in 4.1.
Yeah, it's an old feature, and I'm like, how did I found out about it when I was writing my book, and I'm like, I wonder what this checksum thing is, because now I have to explain to people what it is. And I had to go in and, you know, the manual wasn't clear on it, because if you type in checksum into the manual, you get like 20,000 pages. So I actually just was trying it out on different things and realized that it only worked for MySQL tables, and that, you know, when I inserted data, it automatically came up, and, you know, for DVD tables, the checksum is always 0, because for whatever reason, the way that stuff is done is it doesn't show up as null if it doesn't exist, it shows up as 0. Same things with things like data free and all that kind of stuff. It'll say 0, which freaks people out. We're like, data free 0, oh my god, my table's going to explode. You're like, no, that storage engine just doesn't handle that field. And, you know, instead of putting null, it's 0.
What's the weight? So assuming you're not doing any of the pre-checksums, so you can't narrow it down to a chunk. Let's say you just have a large, like 100,000, not large, but like, you know, 100,000 records that you like 10 or so get added to at the end every couple hours or every couple minutes or whatever. to run this, how long does it take to do checksums on like row by row? I mean, is this a pretty lightweight process?
It's really dependent on like the hardware and the size of the tables. I mean, it really depends. So for larger tables, you can actually break this up. There's like sleep options and coefficient that you can actually say like, oh, slow this down and throttle it so it doesn't impact the server. So you can do that, but it's really dependent on the system, right?
Well, so what does the implementation look like? Is it like insert select that it does? Like
No.
It doesn't replace, well, the checksumming doesn't replace into for the table. What this does is it does do insert select,
Right.
because that would be different, it might be different on the master and slave. It'll do like delete and then insert into table hard-coded values, so.
So it is hard-coded value, so it doesn't slow your replication stream down.
Correct.
Like using some big select.
Yes.
Okay.
Right,
Yeah,
yeah.
it's individual statements, so you'll
Yes.
see.
Yeah,
Which
that's
is
what
why I
was
like to
wondering
type it
about.
into a file so I can see, and what it'll do is it actually groups them. Like if you have a whole lot that's different, you'll see like all the deletes first and then all the inserts.
Oh, sorry, I'm not talking about sync, I'm talking about the checksum.
For the checks.
Oh,
Check.
for the checksum, yeah, it's possible that it can block it. So there's like, there's actually options like, I think there's a slave lag option that actually says like, check to make sure that the slave is lagging by this much. If
Yeah.
so, break it up into chunks and stuff.
Yeah. I guess what I should do is I should run it on QA and look at the SQL that it's actually spitting out to see if I can.
Yeah, you'll see it does
That makes
replace intos, and one of the things I thought that was on these slides, but it's not. So the interesting thing is because you would want to know if the values are different on the master and slave, it actually specifically uses statement-based replication. Even if you're using bin logging or whatever, it specifically uses row-based replication to statement-based replication to do those statements, and it changes the session value. So you might get statement not safe for for replication in the error log.
Couple questions.
Sure.
First of all, what checksum function is used?
What checksum function is used? CRC32, I think.
Any way to change it?
Yeah, there's different options. Look at the man page.
Okay.
Yeah, there's dash algorithm. There's like bit XOR.
Yeah,
There's.
there might be a better way to reduce the
Let's filter.
collision.
Oh, sorry, exit.
Because if you're encountering a lot of times when you run it, a checksum collision, that's not really good.
Well, yeah, and there are false positives and false negatives sometimes,
Huh.
So there's
So
here are the different hash functions.
Oh,
Right?
okay.
MD5 should be good enough.
Yeah.
Okay.
What's the default?
The default is bit XOR, I think. I think it's this one is the default. Oops, sorry, this one is the default. I don't remember. It's
Scroll
default.
up, it'll say.
What?
It should say, if you scroll up well, under the dash logarithm section.
Here. The three basic algorithms are different are checksum, bit XOR, and a queue. Checksum cannot be used. So checksum is the whole table basically, which will lock the whole table. So it'll try to do the whole table because that's the easiest. And if you can't do the whole table, it'll try bit XOR. If you can't do that, it can't do that. So bit XOR requires version 4.1.1 or later, and it won't do checksum if you have any of these. So basically, if you're using chunks or you're filtering something out or you're saying since a certain time, it can't do the whole table. But if it does try to do the whole table, like that's its preference, it'll just use the regular checksum function. Otherwise, it'll use bit XOR and then it'll use a queue. So I think in the float example, we actually used the queue one because bit XOR wasn't showing up. It was like, nope, there's no differences. So, and there are times that we've used one of them and it showed that there were differences and we did a MySQL dump and there weren't differences. Again, not 100% perfect, but 98% perfect is a whole lot better than not knowing. So what we ended up doing is in the where clause when we did the select from the slave to say, show me where this CRC doesn't equal master CRC, we would filter out other tables. Table name isn't this because we know that table name is wrong. That table has, float precision data, it's just going to be wrong, and that's okay.
And the second question, is it possible to specify table names as a regular expression or something like?
You can pass in the table name.
Yeah. So the question is it possible to specify table names?
So just do like these 10 tables?
No, say table like and then prefix.
Oh.
and then
Right,
percent
you want
sign.
all the tables that begin with, WordPress
Right, right.
something.
I don't think that's out there. I don't think it is.
Well, it's Perl, so you can write it really quickly.
Right.
Yeah, you
There's
could just
wait,
select
there's a
from information
databases
schema,
regex,
get the
so
table
there might
names.
be a table.
Oh, I just never looked at how it's done.
It's table here, yeah, there's,
Yeah,
there's
there
gotta
is
be,
a-
there's
yeah,
a
there is.
tables
Yeah,
right
yeah.
next. Yep,
Oh, there you go.
there you go.
So yes, there is a table right there. So you
So yes,
Oh, okay, great.
but you do want to be careful because this is a command line thing, so if you're putting weird characters in the command line, you want to escape them and.
No, it's typically just a prefix.
Right, but yeah, okay, so it's not a weird, it's not
No.
using commas or
No.
whatever.